All right, so let's look at this question. Says evaluate. We are dividing into complex numbers. Whenever you divide into complex numbers, you just have to multiply by the conjugate of the denominator. The conjugate of the denominator is a complex number, but with just a different sign in the middle, which will be like this. All right, or you can even use the numerator. All right, it does not matter. We together. So you can use the numerator or the denominator. That one does not matter. It's up to what you want. Okay. All right. So we can, like I said, the numerator is okay or the denominator is okay. It's up to you. All right. So we have that. Then you have 2 minus this. So multiplying this side, what do we get? We have 4 plus 7i. Then we got 2 minus 5i over then 2 plus 5i multiplied by 2 minus 5i. All right, so here what we have got 4 times that, which is what, 8. 4 times this is negative 20 what, I get in the concept, negative 20 what I, and this one times that is what, 14i, then this and that one we get negative 35 I what squared over, this is the difference of two squares, by the way, so when I multiply I'll just get this one and I'll just square it like that. We get it, which is just just this 2 squared and this one squared and that one squared. So this one gives us 8 and all right, so here we get 8. All right, then this is in, we know that I squared is equal to negative 1, so here we have positive 35. So we have positive what, 35. Then here what we get negative 6 what, I over, this is 4, and we get negative 25 what, I squared, of course, that is negative 1, so we get negative 1 there. So what we have there, for what, 43 minus 6i over what, 29, which can now be simplified as this, minus 6i over 29. Let's look at another one. 2 1 over I. Can you simplify this one? All right, simplifying this one, what we do, we know that this one is just the same as I plus 0i over 0 plus I. We know this, isn't it? Which we can now multiply by the conjugate of this one, which is 0 minus I over 0 minus I. So we're multiplying this now. So 1 plus 0i and 0 minus I over 0 plus I, 0 minus what, I. 1 times that we get 0, that minus I, isn't it? Here and there, 0. All right, that and that one, 0. So we just end up with this, getting it over 0 squared minus I squared. This will be negative I over what? Negative 1. Okay, there, so we have there is negative 1, but there's also what? A minus. We there, but there's also what? A minus. So if you want to come out 0 times 0 is 0, then that one and that one we get still 0. This one and this one we still getting 0. Then that one times that one we are getting negative I squared. That's how come I got negative I squared here. All right, which now we have got a negative there. Let me do this. So I got negative I there of, you get it, Then here, what do I remain with here? I have negative and negative like that. You get it, which will be that over 1, which is just what? Negative I as the answer. Let us plot these complex numbers. Let us plot them. Now you know that in the y-axis, that's where we've got our imaginary part, all right, and in the x-axis, all right, and in the x-axis, that's where we've got the real part. like that. So with this one, the real part is 3 and the imaginary part is somewhere 4 there. So we have our complex number there. Done. Next we have this, which is b is z is equal to negative 1 minus negative 4i. So we know that our real part is negative 1, so negative 1 there. Real, imaginary. Then we've got, in the imaginary, we've got negative 4, which can be somewhere there. Alright, then we can have somewhere there. So that is our complex number. Let's look at another one. Question 3. We are plotting this one. 3i. Good. So in the imaginary and in the real, this one just the same as z is equal to 0 plus 3 what I. We don't have in the imaginary, it's just 0 there. So and there we've got 3. So it's just there. So just show it by an arrow. Done. Alright, all of this one. Z is equal to negative 2. Can you plot this one? Alright, just the same. Imaginary, curve real, negative 2 somewhere here. So this is where it is. Let's look at something else. Next, let's find the modulus of number 1. Z is equal to 3 plus 4i. Now to find the modulus of z, just given by squaring the real part and also square the imaginary part. So the real part is just 3 squared. That will get 4 to give us 16 plus what? 9 to give us 5. 9 as a modulus. Then b, z is equal to 1 plus I. So z modulus is equal to this is 1 squared. The coefficient of I is just 1 as well. We have that. Let's give us 2 like that. Done. Follow this one. We'll end on this one. Z is equal to negative 2 minus 2i. So this one is just the root of negative 2, you square it, minus, sorry, plus, again you square it, which will give us 4 plus what? 4 under the root, to give us root what? 8, which you can simplify as z is equal to, we know that root 8 is 2 times 4, and here we know that the square root of 2 times the square root of what? 4. So z is just equal to root of 4 is 2, then root what? 2. That is if you know what we are doing. If you don't know what we are doing, just end there. Next, we are going to find the argument. Alright. Alright, so we know that the argument is just the angle. Alright, and the argument of an angle, theta, is just given by tan inverse of y over x. In most cases, if you cannot find the tan inverse of x and y, you can use cos and sine. Alright, where we know that cos theta is equal to x over the modulus, and we know that sine theta is equal to y over what? The modulus. Then from here you are going to find the common angle, then you can find that angle. So looking at this one, the one that we have here, z is equal to 1 plus I. The first thing is that find the modulus. The modulus is 1 squared plus 1 squared, everything over what? That, which will be root what? Root 2. Now let's go on and find cos theta. Cos theta is x over what? R. What is x in this case? It's 1 over root what? Root 2. Let's go and find sin theta. Sin theta is y over r. And y in this case is just what? 1 as well over root 2. Then you find yourself what's your common angle. Alright? That common angle, when you punch it, is going to give you this, is just 45 degrees, which is pi over 4. Are you getting the concept now? Eh? So this and this is just an angle which is common for both sine and cosine. Alright. Therefore, you can conclude that the argument of z is pi over 4. You're done. Let's put another one. Z is equal to 2 root 3 plus 2i. Step 1, find the modulus. So I have 2 root 3 we square plus 2 squared. Everything under the root. Are we there? Now square 2 is 4. Then when you square this one, you just get 3. Plus what? 4. Which will give you 12 plus 4, which is root 16. This one I'm getting 4. So my modulus is 4. Now that I know my modulus, I can go on and find cos theta. Cos theta is equal to x over r. What is our x? Our x is this one. 2 root what? 3 over 4. To give me what? Root 3 over 2. Sin theta is equal to y over r. And what is y? Y is just 2 over what? 4, which is what? Half. We are still looking for a common angle such that when I punch it in terms of cos, I'm going to get this one. In terms of sine, I'm going to get half. And that is 30 degrees. And 30 degrees is just pi over what? 6. You can now conclude the argument of z is equal to pi over 6. This is how you do it. And you can also verify this, that this is where your angle is going to lie by, you can plot that complex number before you even go anywhere. Let's look at number 3. You'll see what I'm talking about. Z is equal to negative 1 minus I. What is the modulus of this one first? It's negative 1 squared plus negative 1 squared. Everything under the root. Just give us what? Root of what? Root of 2. This is a modulus. Now that root 2 is a modulus, we know that cos theta is equal to x over r. What is x? X is just negative 1, so negative 1 over root of what? 2. Sin theta is equal to y over r. What is y? It's also negative 1 over root of what? Over root of 2. Now, what common angle are we talking about? First of all, in terms of negatives, I advise you do what? You plot the axis there. Plot this one. This will be negative 1 and negative 1. So our angle must lie in the third what? In the third quadrant. So our angle lies in the third quadrant. Alright? And we know that in the third quadrant, both sine and cosine they are negative. That is a fact. So to do this, we know that this and this is just negative. Alright, this angle here itself is just negative pi over 4. Just negative 45. If you look at it, this is just negative 45. Alright, but is our angle is the negative 45 in the third quadrant? No. You get the concept, right? Negative 45 is not in the third quadrant. So what we are going to do is this. We are going to say, in the third quadrant, how do we find the angle? So in short, pi over 4, this one, is just our reference angle, the one you used to write as this one is our reference angle. But now we need to find the actual angle. So the actual angle in the third quadrant, how do we do it? We'd say it's usually pi plus the reference angle, right? In this case, our pi. What is our reference angle? Our reference angle is pi over 4. This is 5 pi over 4. See now? I've taken pi as positive, or I can say theta is equal to pi plus this one, which is theta is equal to plus. Now if I take this one to be negative, remember it's also negative. On the other hand is negative, on the other hand is positive. Why is it that on the other hand is positive and on the other hand is negative? Well, cos is even, sine is odd. So for cos it will be positive. That's why I took it as positive. But for sine to be negative because sine is odd. So I'm going to put positive pi over negative pi over 4, which will give me 3 pi over 4. This, therefore, I can now say the argument of z is equal to 5 pi over 4 or 3 pi over 4. If you want to try to punch them, you're going to get the same answer. All right, ladies and gentlemen. All right. In fact, negative. Yeah, this one should be negative as well. It could be the same, but because you see sine is negative there, so it will be negative as well. All right. Another one, the last one. On the same, z is equal to root of 3 minus I. What's your modulus? Modulus is root of 3. We square it under the root. There's minus here, so plus negative 1 squared, which is giving me root of 4, which is what? 2. Now, this is 3 plus 1, 4. That's how come. Alright, so cos theta is x over r. What is x? Our x is root of 3 over 2. Sin theta is y over r. Alright, and this one, what do we get? We get what is y. When you look at y, it's just negative 1 over 2. We are looking for an angle like that. Alright, now we know that from the word go, this complex number is actually, so this is can be our root 3. Sorry, not root 3 there. It's positive, so this somewhere here we can have our root 3. Then negative I somewhere down here. Then we have that. So our complex number is actually in the fourth quadrant. Now the angle itself, the angle, which angle gives you half for sine is theta, right? Which that same angle, it gives you root of 3 over 2 in terms of cos, right? You know that the reference angle is pi over what? Over 6. All right. Now this is in the third quadrant. So in the third quadrant, what we do? The theta will just be equal to 2 pi minus pi over 6 as a reference angle. This is 12 minus 6, which gives you pi, which is 11 pi over 6, like that. Alright, now because it's in the third quadrant, none of them is negative. So only one is negative. So we can say, because only one is negative, this will be also like that. Alright, so in the fourth quadrant, the angle can be 11 pi over 6 or negative 11 pi over 6. Listen, simple. One is positive, one is negative. Done.